So for this video, I'm going to show you how to read a diagram like this. And I'm not going to focus so much on doing the math on it, but I'm going to show you the different parts of the diagram. I know that this part of the diagram right here is reflected out by the light, so I don't know if you can actually see it or not, but this is a flat section right here. I don't know if that helps or not. Anyway, this is a staircase diagram. It's really called a heating curve. Okay, heating curve. It's not curved. Okay. But it's got some pieces, got some parts, right? It's got 1, 2, 3 slanted sections. And it's got 2 flat sections. Okay? The flat sections represent a change. That's where something's happening. The slanted parts are where you're heating something up and it's getting hotter, right? Temperature, in this case, is on the y-axis. This is my temperature. On the x-axis is heat. Okay. Sometimes they'll write time, but that's just a way of saying heat. Okay? So, 3 phases of matter that we care about, solid, liquid, gas. 3 slanted sections. Coincidence? I think not. How do you know which one is which? Go to the lowest temperature. On the y-axis, things that are really cold are frozen, right? So this would be solid. And then way up here at the very high temperatures are a gas. So the one in between is a liquid. Okay? So this is kind of different from the claw diagram, right? Again, the flat sections are when we're changing from one phase to another. So what is the phase change between solid and liquid? Melting. I hope you can read that. Okay. And then over here, this would be vaporization or boiling or evaporation. Vaporization. There we go. I can spell. Okay, so you've got these parts to this graph, right? The things to know here is if it's flat, that means the temperature isn't changing. So this flat section right here and this flat section right here is when you're changing the phase. During a phase change, the temperature stays the same. Why? Because only potential energy is changing. When temperature goes up, like on this slanted section here, and this slanted section here, and this slanted section here,
kinetic energy.
That's when kinetic energy is going up. If temperature goes up, kinetic energy goes up. But if temperature stays the same, if you have a flat line on this graph, that's potential energy. Now, I'll do another video here in a second where I'll show you how to find the latent heat for melting and the latent heat for vaporization. But that's all I want you to do here is read the graph.